Okay, so question number 10 is to give the full electron configuration of iron. Okay, so when writing out the electron configuration, there are different steps that you can take in order to write the full electron configuration. So step 1 is to divide your periodic table into the different orbitals. So S, P, D, and F. And I can show what that looks like. Like so. And you kind of get something that looks like this. So for the leftmost columns, this is the S block, including helium. And this green section is the P block. And the middle transition metals is the D block. And the last two rows, the lactanides and actinides, is the F block. So now, starting from hydrogen, we move left to right across the periodic table until we get to our desired element. And then we write the row number followed by the block letter. And then in the superscripts, we show how many electrons are in each of those orbitals. Using superscripts. Okay, so I'll also add that when we get to the D block, we write the row number -1. And when we get to the F block, we write the row number -2. Okay, so now let's try to do our example, which is iron. So iron is found here, right in the middle of the transition metals, atomic number 26. So starting from hydrogen, we move left to right across the periodic table, and we write the row number, which is 1, the block letter, which is S, and then we write how many electrons are in this 1s orbital. So in this case, there can only be 2 electrons in an s orbital. So we write a superscript of 2. And this only brings us to the electron configuration of helium. But now we move on to the next row. So row number 2, the block letter is 2s, and then there are also 2 electrons in that orbital. Then moving over to the P block, we're still in row 2, and we write P, and a P orbital is able to have 6 electrons. And now moving over to row 3, S2, and then 3p6, and then we can move on to the next row, which is 4s2, and then iron is in 3d, And then we count how many electrons up to the iron. So we count 1, 2, 3, 4, 5, 6. So we write 3d6. So this is the full electron configuration of iron, but we can also write the shorthand configuration. So when writing the shorthand configuration, we write the noble gas that comes before iron in square brackets. So in this case, it's argon. And then we just continue on writing the remaining electron configuration as normal, or S2, 3d6. Okay, so let's see what the junior tutor said. In writing the electron configuration of an element, we follow the Aufbau principle shown below, which states that the order of energy will dictate the order in which electrons are arranged in their orbitals. Therefore, the lowest energy will be occupied by electrons first. So this is a different method of writing electron configuration. So it just depends on what you're comfortable with, but you can write all of the 1s up to 7 in a column, and then kind of align it with the 2p up to 7. The 3 goes up to 6, and then 4 goes up to 5. And then to find out the order, you kind of go diagonally like this, and you can still get 1s, 2s, 2p, 3s, 3p, and then 4d or 4s, and so on and so forth. Remember that each orbital can hold a different number of electrons. The s orbital can hold 2, p orbital can hold 6, the d orbital can hold 10, and the f orbital can hold 14. So since iron has 26 electrons, using the Aufbau principle, they wrote out their electron configuration. Yep. So this solution is correct.